Hello everyone, welcome to 24 hours of PaaS Summit 2015 preview. Very good morning, good afternoon or good evening to all of you depending on which part of the world you joined from. We are excited that you could join us today for Allan Mitchell's session, Building a Scalable Analytical Solution Using Infrastructure as a Service and Elasticsearch. This 24 hours of PaaS event consists of 24 consecutive live webcasts delivered by expert speakers from PaaS community. This session is a preview of one of the many technical sessions that will be presented at PaaS Summit in October this year. Recordings will be available in 1 week at www.24hoursofpaas.com. My name is Praveen. I'm a SQL Server professional and a member of PaaS. I have few quick introduction slides before I hand over the presentation to Allan Mitchell. He will speak for about 40 to 45 minutes and then we'll move on to the question and answers where you can ask if you have any questions. During the webinar, if you require any kind of technical assistance, you have any questions or experiencing any issues, you could just type them in the question pane on the GoToWebinar control panel and someone will assist you. Please feel free to enter your questions in the Q&A field at any time. Once we get to the question and answer portion of the session, I'll read out your questions to the speaker. Since all the attendees are muted, you will need to submit the questions by typing in the QA field. And also there will be a short evaluation at the end of the session. Your feedback is very important to us, so please take a moment to complete it. It will appear in your web browser. 24 hours of PaaS would not be possible without the support and dedication of our sponsors. They are the reason this event is available to you free of charge. So I would like to take a moment to thank our presenting sponsors, Microsoft, Dell Software, and Idera. In addition, I would also like to thank the supporting sponsors for the event, HP, SQL Sentry, and Pyramid Analytics. Can we go to the next slide, please? Next, I would like to bring your attention to the upcoming PaaS Summit. It's taking place in Seattle, Washington from October 27 to 30. PaaS Summit 2015 will feature over 200 sessions with world-class SQL Server experts, planned and presented by the SQL Server community. For the SQL Server community, PaaS Summit is single-handedly the largest gathering of SQL Server and business intelligence professionals in the world. With over 5,000 registrants from all over the world, PaaS Summit is also a great place to network and meet face-to-face with the experts, peers, and the most valued professionals. More importantly, PaaS Summit delivers on providing you with the answers to the SQL Server issues along with the knowledge, strategies, and skills you need to stay ahead of the curve. You could save $200 right now by using the discount code 24HOP15 when you register. So if you register before Sunday, September 20, you could optimize the savings. To find out more about PaaS Summit, visit www.paassummit.com. Next slide, please. And make sure you have explored everything PaaS has to offer for data professionals. You can join the local user groups around the world, various virtual chapters, find free online resources through our learning center, and read up on the latest community news in the Connector newsletter. For those who in business analytics, check out the PaaS Business Analytics Conference happening in May next year. Visit www.paasbaconference.com for more information or to subscribe to our bi-weekly business insights newsletter. Next slide, please. And now please allow me to present the speaker of the hour, Allan Mitchell. Allan Mitchell is a SQL Server most valuable professional and runs the consultancy Elasticsearch, helping customers to make informed decisions about their data storage and integration. His focus is on enterprise search as well as real-time business integration. Now I would like Allan to take over the presentation.
Thank you, Praveen. Good morning, everybody. Good morning, good evening, whichever part of the world that you're in. I'm glad that you could join me today for this introduction session to my 3-hour session that's on at the PaaS Summit in October. I'll be speaking on the Friday, but there's a slide at the end to remind you when you can all come and see me if you're going to be attending Summit. So let's get started then. Okay, this is me. Praveen nicely introduced me. I also organise a conference in the UK called SQL Bits. I've spoken at PaaS Summit before. I do SQL Saturdays as well around the world, which is a really great way of getting speaking experience and getting to meet more and more people. I'm Allan SQL IaaS on Twitter, and there's my email address. Contact me. I know we're going to have question and answers at the end, but if there's something that you go back to work or you wake up in the morning and think, you know what, I wish I'd have asked Allan this, ping me. I'm usually more than happy to answer people's questions. I know it's not always possible to think of questions at the time. I've been there before. Okay, so my session is a 3-hour session, and conveniently I've managed to break down my session into 3 parts. They're not equal parts, so I won't be speaking on each part for an hour. The main parts of my talk will be on how we get our on-premise solution to the cloud. And we'll be using infrastructure as a service and Azure Resource Manager templates. So ARM templates are probably going to take up the largest part of this solution, this presentation. Then we're going to look at something called Elasticsearch. Elasticsearch, I'll explain what it is, how do you use it, where would I use it, and at the end I'll give you a demonstration of some of the things that you can query and see how quick it is and see some of the powerful parts. Then we'll look at a tool called Kibana. Kibana allows you to visualize your Elasticsearch indexes. So when Elasticsearch indexes its data, you put Kibana over the top and it allows you to run some visualizations. And this is the part that I think usually works best with people, is when they see, rather than seeing the raw queries, they really take to Kibana. And I'll compare and contrast it with something called Banana, and also if you're in the search space you may have heard of Splunk. So we'll have a look at those. Okay, so IaaS. So this chart shows the top cloud computing drivers. Now it's from 2013, but it's probably still valid for today. And there's a couple of things on there that I think really drive people towards the cloud, and it's scalability, easy scalability, so you don't have to go out. If you run out of resources with an on-prem solution, you generally have to go buy another server, or you have to go out and buy something, whereas oftentimes with the cloud you can scale naturally. Reduced costs, you pay for what you use, right? And you can spin up a resource, use it, do your work, tear it down, pay your bill, and away you go. And speed of deployment. I think with cloud solutions, this is the one that really gets developers, is that they don't have to wait for a new development server to come online. They can provision one in the cloud, deploy their apps, see how it works, and away they go. So and cloud is here to stay. I see more and more people investing in cloud, not wholeheartedly, so they don't suddenly move everything up to the cloud, but what they do is I see a lot of hybrid architecture. Some parts of solutions stay on-prem and some parts go into the cloud where it naturally makes sense. Okay, so we've covered a couple of these, but why infrastructure as a service? And you'll see that some of those really make sense. So lease rather than buy. If you need compute power for only a small part of the month, then why do you need to buy 100 servers when you could spin up the same in Azure or other clouds and use it, and then tear it down and just pay your bill? You don't have to wait for the servers anymore. Yeah, you can choose what you want, the size that you want, and provision it, and about 20 minutes later you will have exactly what you want. Low maintenance, you don't have to plug it in, you don't have to find a plug socket, you don't have to find a network socket, it's already there for you. And IaaS looks very similar to on-premise. So it means that you can take your on-premise solution and move it to the cloud with only a few compromises. And that's what this session's all about. This session is about taking a non-Microsoft product, Elasticsearch, and taking it and deploying it to the Microsoft cloud and still being able to use it from your applications just as you would if it was in your own data center. There's also a PaaS, which is Platform as a Service, and IaaS makes sense if PaaS doesn't have what you want. So if PaaS doesn't give you enough control, or maybe the features aren't there, then IaaS is definitely an alternative you might want to explore. So what can we do with infrastructure as a service? So for us, for our session where we want to move Elasticsearch, these are the things that we're going to want to be looking at. We're going to need some virtual machines, right? So we're going to need N virtual machines. We need something to run our software on. We need storage accounts because we're going to have to provision disks, put them onto our virtual machines, and then we'll load software on. So we're going to need storage resources. Then we're going to need a network because all of our compute resources need to find each other, and they'll do that through a network interface. We'll put everything behind a load balancer. So a load balancer will allow us to address our resources through a common address, and it will balance the traffic over the nodes in our Azure Search cluster. And then we'll give all of our nodes IP addresses as well. So there's quite a few things there that you can do, and quite a few things there that you've got to think about. Not every solution will require all of these things, but for us, we will need to build all of these resources. So deploying to Azure, how do you do it today? Use the REST API, you create a new VM, you deploy a website, you add storage. What about if your website needs a database? And this is the canonical example. For what we're going to be doing for the templates, this is the canonical example that everybody cites is, okay, you want to deploy a website, but at the same time you will need to provision a database server at the back and make the two talk together. If you go search on Bing, you'll find this is the result. This is the example everybody uses. So with different VMs, you often need extra disks of different sizes on the same network, and you need to have different resources in your solution. Then you need to provide permissioning, you'll need to do monitoring, cost, obviously. And whenever you're deploying anywhere, so this is a big thing with on-prem as well as cloud, right? So this is the whole continuous deployment, integration, make it reliable and repeatable. So reliable and repeatable, things like Chef and Puppet. You look at those, they've been around a little while now. They do a very, very similar thing to Azure Resource Manager template, something that you may be familiar with already. And people want to do this on-premise as well. I work with people who want to rebuild their environment in dev every night. So they want to tear it all down, rebuild everything, deploy the software, and then they know in a disaster I can rebuild the whole of my environment by the push of a button. And that's exactly what we want to be doing when we're deploying to Azure. Because if we're deploying a complicated infrastructure, SharePoint for example, we want to make sure that when we push that button, it's tried, it's tested, it does exactly what we want it to do. Okay, so these are the different types of cloud models. So as you know, there's different types. Now the first one's obviously not a cloud model at all, it's on-premise. And this is where you manage absolutely everything. You've got control over absolutely everything. So from the networking stack to the operating system, any virtualization that you want to do, right through to your data and applications. And this is the traditional way that people have things. But then we've got infrastructure as a service, which is one step removed. So generally your vendor will provide the lower levels. Few of them provide an operating system, and you're responsible for the app. Devs like this model as there's no concerns about physical or virtual machines. So they can just provision ones. Remember what I was saying earlier, they can just provision resources and deploy their apps to it. They don't have to go ask for somebody to go buy a new server so that they can work with their apps. And this model was the primary reason for Amazon Web Services was their EC2 offering, which was infrastructure as a service. We then got platform as a service, which moves us one step further away, and this is where your vendor will not only manage the physical layer, but they'll also operate the application runtime, or they'll manage the runtime. You just have to worry about the application and data. So devs will be more concerned or spend more of their time looking at the business logic that their application needs from platform as a service rather than the application itself. So an example might be Azure Search is platform as a service, DocumentDB, Azure Data Factory. You don't manage any of the underlying runtime or the servers or the clusters that are built underneath. You just worry about, okay, so how do I build my indexes? How do I define my sources, my pipelines, my destinations? How do I do that? And that can often be extremely productive. Platform as a service can be extremely productive. And then you move through to software as a service, which has been around for a good while now. And everything is managed by your vendor. But we're going to be concentrating today, obviously, on, or rather this session at Summit will concentrate on infrastructure as a service. Okay, so resource groups. They're an important concept. They have some very important features. So you can manage all of your resources in a resource group as a single unit. You can manage role-based access on the groups and resources. And you can also do targeted billing, so you can create a resource group and make that a billing unit. And it can, if your requirements are such, it's easy for you to bill back to a certain department or a certain customer. You can manage and monitor your solution as a group. You can repeatedly deploy and know that whatever's in that resource group is consistent. So you can continuously deploy, and it will be consistent. You can apply tags to logically organize your resources, which provides better billing. With resource groups, applications that have the same life cycle, i.e. they should be deployed together, and when one thing changes, the other things will also change in line. They should go in the same resource group. Things that have a different deployment cycle, so for example, it might be that you've got a bunch of resources and they consume a SQL Server database, but the database you could be deploying every day, every hour. You could be doing a whole load of changes or need to deploy it on a different time frame. You'd put that in a different resource group, and through resource group linking, you can create the link between resource groups. Belongs to a single resource group. A resource can only belong to a single region, a single resource group. But inside a resource group, you can have multiple resources from different regions. So it's not, the resources within your resource group don't have to live within the same resource, same region. So templates, like I said, are equivalent to Puppet and Chef, which some of you may have already heard of it, but it's a declarative way to describe your architecture. Now, I think this is becoming more and more prevalent. As I go around the SQL Saturdays and I look at people's blogs, I see people talking about, because we're SQL Server professionals, I see them talking about BIML, right? Business Intelligence Markup Language. So Business Intelligence Markup Languages allows you to define metadata, and it will go away and you can construct packages, integration services packages. Azure Resource Manager is pretty much exactly the same. You define what you want, how you want it, and say deploy, and Resource Manager will go away and build your infrastructure for you. The good thing about that is when you want to do it again, you just deploy it again and it will build again. And if you deploy it somewhere else, it will build that again. It is predictable. It is repeatable. If you have the need just to build one VM, maybe you choose not to use Resource Manager template. Maybe you just do it manually. Maybe you go to the portal and do it manually. But what about if you want to deploy 1,000 VMs? No problems. In our solution, we're not going to be quite that grandiose. We're going to keep it at about 4 VMs. So we're going to create a 4-node cluster. But if you want 1,000 VMs, you can have that. And the code is exactly the same. You just change how many instances of the VMs that you want. And all of the things that you need to do, you can do it. Do you need to provide custom code? So we do. So in this solution, we need to install Java for a start, and then we need to deploy Elasticsearch. We can do that with Resource Manager templates. We can do that. We can go get Elasticsearch. We can go get Java, and we can configure them. It's not a problem. So Resource Manager templates are your way of having a prescriptive, declarative way of saying, this is what I want my architecture to look like, and it will be predictable and repeatable. And that's something that we should strive for. Okay, so this is what our architecture will look like. We're going to have a virtual network because, like I said, we need to have the ability for all of our nodes to talk to each other. We're going to have a load balancer. We're going to open up a port public side of 9200 and we'll open one into our cluster at 9200. So we'll create a mapping on our load balancer. There's 9200 to 9200. And the load balancer will address the nodes in the cluster, and it'll do that round robin. The nodes in the cluster will need storage. So we'll add storage to the virtual machines. And we'll also need to, like I said, the first thing that we're going to need to do is install Java. Second thing that we need to do is install Elasticsearch. The next thing we need to do is configure our cluster in the elasticsearch.yaml file. So all the nodes will then be able to see each other. They'll all be part of the same cluster, and they'll all be able to share data through sharding and replication. Then we'll have a client which will come along and we'll query it as if it was on-premise. So that will be our infrastructure that we will build at the Summit session. When we do it at the Summit, I'll show you the exact resource manager templates that I use to create each of those resources. They're relatively easy to understand. They're nicely broken out. They're broken down into JSON. So JSON is easy to understand, easy to read, and we can build them through that, and we'll build them through Visual Studio. Okay, so Elasticsearch then. Everything begins with search. So I remember talking with some people and saying that everything begins with a search. When you go to a website, generally the first thing that you do is you want to go and search for something, and then you'll refine your search later. If you go on to something like Amazon and you're searching for a book, you'll type in Harry Potter, and then you'll get your categories down the left-hand side. It'll start to list some things, and you can start to refine your search. And then you're performing other parts of search, maybe without realizing, like highlighting, pagination. That can all be done through search. Elasticsearch is probably in the top two. It's arguable, depends on who you talk to. Solr and Elasticsearch are the two top search platforms out there. Elasticsearch, the name suggests search, and it is a search solution. It's incredibly powerful as a search solution, but it's also incredibly powerful as an analytical solution. And that's what I want to demonstrate in my session, is that I'll load some data and we'll do some querying of the data, and we'll do some analytics over the data as well. It's schema-free. I'll tell you why schema-free. Schema-free, it's true. It's a NoSQL solution, so it's schema-free. When you write, you don't have to write a schema. You don't have to create a schema up front. You can write pretty much whatever you want, and Elasticsearch will interpret what you've just written and index accordingly. So you can have nested JSON documents that you push in, and it will index that accordingly. It's an open source Apache license too. Sensible defaults. So the defaults that it applies are pretty good. So how many shards you have, how many replicas, etc. There's a whole family of plugins, and I'll show you one which is Kopf. So you can manage your cluster through these plugins. You've got automatic replication, failover, and sharding of your Elasticsearch indexes. It's based on Lucene, so Elasticsearch and Solr are both based on the Lucene library. And there's a very rich query DSL. It is very rich. You can do an awful lot of stuff in there, but it can become a little complicated. So what we'll do is we'll have a little look. And at the end of my slides, what I'll do is I'll break out into the browser, and I will show you some queries against a relatively small Elasticsearch install that's local to me now, and there's 6.6 million documents, I think, and I'll just show you how fast you can work on it, and some of the queries that you can do, and then we'll show Kibana as well. So I thought I'd add this table as well, just so that we're all probably database professionals, and I just wanted to map that to what Elasticsearch talks about. So a database, really an index. A table is a deeper definition within an index, within a database, and likewise type is a deeper, a subgroup of index. A row is a document, columns are fields, and the bottom one, schema and mapping. So Elasticsearch, like I said, is a NoSQL solution, so it doesn't have to, you don't have to, when writing, you don't have to define a schema up front. What you might want to do though is you might want to define a mapping, and a mapping allows you to say, when you see a string field, please create a not analyzed version of any string field that you see, because I want to see, I don't want you to tokenize that particular field. I want to see that field as is. You can have it tokenized based on a specific tokenizer. You can have a language applied to it. You can say that it's a geopoint data type. When it sees something, it's a geopoint data type. You can tell it that this field will represent the timestamp for the document, which is useful when you're using Kibana. So yes, you don't need to provide a schema, but sometimes you need to give a little bit of a helping hand to Elasticsearch and say, okay, I know a little bit about this data set, so for these odd attributes, I want you to treat them in this particular way for this particular index. Once we've installed Elasticsearch, we can go to port 9200, and with a bit of luck, we'll get something like this. Yeah, yours, if you install it now, you won't get this exact screen, this exact slide, but you'll get something very, 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 very similar. So that's how we know that we're up and we're running. Search can be more than you think. So for some people, search is looking for a given word and please retrieve me document. Search can be more than that. So unstructured search. Think of a text box on a web page, you type something in and away it goes. The website up front has no idea what you're going to type in. So that's unstructured. It's up to you. It's free flow. And then you get structured search, which if you go to some product websites, you type in Harry Potter. And then you'll see down the left-hand side, it'll categorize things for you. So star ratings, categories, pricing. Those are facets. In Elasticsearch, they're called aggregations, but in Solar, they're still called facets. Highlighting. Look in all these documents and bring them back and highlight where you find the search term. Suggestions, did you mean? Sometimes we don't actually know what it is that we're looking for, so it might be that if you're wondering whether it's license with an S or license with 2 C's, you might type in license with 2 C's and you might want it to bring you back, well, did you mean license with an S? And you say, yeah, I meant that. And away it goes. Pagination, so you can break your search results up, and more like this. Kind of like a recommendation engine, I guess. It's where you can say, okay, I'm looking at this type of document. Do you have anything else that's very, very similar? And it'll do that based on the term vectors that are within your document that you're currently looking at. It will go and look for other documents with similar term vectors, and it says, you know, you might be interested in this. So you can see that search isn't just about pulling up a particular web page. So what are we going to need to do when we do it? Simple. We're going to have to install a Java distribution. We're going to have to install Elasticsearch. We're going to have to add Java Home, because Elasticsearch, even though you've installed Java, if you don't have a Java Home entry in your environment variables, it'll not work. Alter elasticsearch.yaml. So this is Elasticsearch configuration file. This is how it knows who it is, where it is, and what it should be doing. Open up any ports, so we'll need Elasticsearch, the nodes in the cluster to talk to each other, and then we'll install any plugins that we need. I'm a particular fan of Kopf, and we'll install that. So that's what we're going to need to do as far as Elasticsearch is concerned once we've provisioned our 4 VMs. Okay, so Kibana. Kibana, not banana. The reason why when I gave a presentation with Jen Stirrup once, we did Cabana, and she had Cabana, not Copacabana, which is probably funnier. But Cabana and Banana are if you live in the search world, they're very similar, right? So this is Cabana. Cabana is the visualization engine on top of Elasticsearch. Banana is the visualization engine on top of Solar. So very similar. One's Banana is a fork of Cabana. So it started out. If you go look for Banana after this webcast, you will find put screenshots of the two together, and they are insanely similar. Okay, so it's a highly customizable dashboard for Elasticsearch, and like I said, ports have been done for Solar. You can make sense of your data. Sometimes it can be easier just to use a visualization, as we all know, so Power BI is extremely useful for being able to look at your data, and Cabana is extremely useful to be able to look at your data that's held in Elasticsearch. You can do time-based analysis, so it may be that you're looking at, I don't know, a canonical example is weblogs. So people use tools like Solar, Elasticsearch, and Splunk to do weblogs to look at threat detection. And you can do that over time, and time analysis can be very powerful. It's easy to set up, and you've got some quite sophisticated analytics that you can do. Now, I'm not a visualization person. Doesn't matter what I do, I can never make anything look pretty. But we'll give it a go, and we'll have a look at a dashboard in a second. Somebody with more visualization skills than I would be able to make it look presentable, something that you could present to the business. So how do you use it? Well, you point it at your Elasticsearch index or indexes, because in Elasticsearch you could have a number of indexes, and maybe you've broken up, because you've got so many documents, maybe it is that you've broken it up into different indexes, so you can actually provide a index name star, so everything that begins with that prefix, you can then search over that. Discover allows interactive exploration of your data, so that's a very quick way of having a look at your data, having a look at the text, playing about with it, seeing the events and the makeup of them. And you can visualize. Visualize is where you build your aggregations, individual aggregations. You can use them standalone, or you can put them into a dashboard. And a dashboard you can share and empower people with the information that you present. So what's available? Area charts, line charts, metrics, i.e. count of events. Pie charts, like them or loathe them, pretty much everybody has pie charts. Tile map, which seems to be very popular, so you can do heat maps. And a vertical bar chart. This is a quick screenshot. What I've done is I loaded some crime data from the UK. So in the UK we publish our crime data. The location is slightly off, so it's not very, very accurate. So you couldn't identify individual properties, but you get the idea of where it would be. So if you look at this one, all I've done is I've said, okay, I want to focus on Kent. I've also provided a time frame in the top right-hand corner there, and then I've provided a metrics, a bar chart, and a tile map. So we can see exactly where the hotspots of Kent happen to be. I'm not going to tell you where I live, but it's somewhere in amongst all of that. Yeah, so that line that you see going from top left to bottom right is along the pretty much along the M2 motorway, the A2 M2. That seems to be a very popular area for crime, or certainly for burglaries. And you can see there's 4,560 instances. So it's very, very powerful, and it's easy to see and colourful. Okay, so before we get to questions, let me just come out of that and show you Elasticsearch. So this is the COPF plugin. So as you can see, I've got a number of indexes. I've got 32 indexes. It's a single node because I'm running it on my laptop. I've got 312 shards, and I've got 6.4 million documents. And you can see that they're broken up into these individual indexes, and they're all roughly, so this is crime data, yeah, hence the word police beforehand. So there's roughly 500,000 documents in each of those indexes, therefore there's 6.5 million documents altogether. So remember what I was saying about providing a mapping? Well, here what I've done is I've created a template that I use which creates the mapping for this police data. And some of the things that I do in there is I say, if you find a string field, then please create a not analyzed version of that string field and give it the name of fieldname.raw. So I can look at it in its tokenized version, and I can also look at it in its raw version. Down the bottom there, you can see that I've also added a mapping for coordinates, and I've said, okay, that is a geo point, and that's going to be useful for us when we use the tile map. Okay, so as you saw, I've got 32 police indexes. So a very simple search is all police indexes _ search. So we can go quickly have a look at that. And you'll see that that came back very quickly, 48 milliseconds, and it queried and it found 6 million documents. And here's the first 100. Yes, so underneath it's all the first 100, and these are the attributes that it found. What we could also do though is maybe we're actually only interested in a particular index. So because when I indexed it through Logstash, I indexed it based on year and month. So it might be that you actually only want to search within a given month, which means that you can break down your search. You don't have to search over the whole 6.5 million documents. You can then search over the, 500,000-ish documents within a particular index. So this one I'm searching for February of 2014. So again, and that came back in 3 milliseconds, and you can see that there's 405,500 records, and we bring it back. When I've been doing this against Azure, I've queried 15 million documents, and the round trip is just over a second. So I get my results back just within about a second, which is pretty good, right? So then maybe what we want to do is we want to do our search, and this search here that I've highlighted is exactly the same as our query 2 up. It's just using more of the query domain specific language. So this one should be 6 million documents, and it is. But then maybe what we want to do is we want to find, give me all documents where the location contains the word shopping. Yeah, so maybe we're looking at, I'm interested in doing a crime search based on being around shopping centres or where somebody in the crime reports mentioned shopping. Okay, there we go. So there is, how many is there? So there's 141,000 documents where the location mentions shopping. So if you look at that, you've got shopping area just there. But maybe we're a specific police force, and we actually only want to research, and we're maybe only doing a specific county. So what you can do is you can do a Boolean filter on your query. So you can say, okay, match against all the documents, but filter, there should be shopping within the results, and it should be in location, but there must be falls within the word Kent, right? So I'm saying there should be shopping, but when the documents come back, you must have the term falls within Kent. If we've only got one should clause, one should item, then that basically maps to a must. One of the terms in a should clause should evaluate to true, but I could add another one in there as well, and only one of them would have to evaluate as true. So you'll see that this this one returned 141,000. So let's see how much this restricts it by for Kent. And you'll see for Kent now came back in 37 milliseconds, and there's now 4,500 documents that came past. Yes, this is all good. This is all good, and the query DSL, you can see how it's very, very quick, and we can do loads of other things like boosting and fuzzy searching. But really what people generally want to do is they generally want to move to something like Kibana. So this is Kibana. So Kibana allows us to pick out an index. So I've actually only got patterns. So I've actually got two. I've got police and I've got web logs. And then it allows us to specify a time frame. So it allows me to do it like this, or I can actually do it more specific by picking dates on a calendar. And then I can choose to look at this, so I can say, okay, I'm interested, let's look at that, that's fine. So let's look at adding crime type. Yeah, so crime type, and I can say crime type, okay, I'm interested in this, so I can further add a filter, and you'll see everything shifts along, and I now get in the right hand side 556,800 documents, and this way is quite interactive, and it allows you to interrogate the data. So you can see that it is a table, which I dare say you're going to want to do, or you can see the actual JSON of the message that you sent in. But generally people want to do a visualization, and this is where you can create your own visualizations. So we can create a vertical bar chart, and we'll create it from a new search, and we'll create it from our web logs pattern. Okay, so at the moment it's just showing count. But what we can do is we can say, okay, so on the x-axis, what I want you to do is I want you to do a date histogram over the timestamp. And then what I want you to do is I want you to break it down and split the bars, and I want you to be able to split the bars by terms. And the field that I'm wanting to look at is client method. And there we go, and then we get a graph that looks like this. So we can use this in standalone mode or choose to add it to a graph. But even in standalone mode, we can look at things and we can say, well, this looks a bit strange, so maybe we want to drill a bit deeper. And what you can see is that also at the top, our date filters have also changed in line with that. We've got our legend over the right hand side, and you can look at this in per 12 hours, and you can look at this and you can do this interaction standalone and very much detailed and look at exactly what you want. So you could look at this and you could say, oh, I don't like the look of that, and it will break it down even further for you. And you can get down to even more specifics and away you go. But this is all over our Elasticsearch data, and this is something that people don't realize that you can do, is that it's not just about being able to search for a product in a product catalog. You can actually do quite detailed analytics with this. And this interface, if you used a product called Splunk, this is very, very similar to Splunk. So let's go back to doing our 2 years worth of data. And then what we can do is we can go and create a dashboard. Right, so let's get rid of that filter. Okay, so what I can do is I can add the count of crimes. So these are visualizations that I've previously created. I can add crimes by force. So it's too small to render, so all I've got to do is I've got to drag it out. I say all I've got to do. Like I said, I'm not very good at making things look pretty. But there we go. We can see that there. And then finally, the crime tile map. So let's leave that there for a second. Now, I live in Kent, and I'm interested in antisocial behaviour. So if you see when I click on this, you'll see that it should add a filter. And what we can do is we can apply. And we'll see that this obviously applies to that. Then you've got 72,000 instances of the crime there. And then hopefully what we should be able to do is in our map, you can see, in fact I've clicked Hampshire, which is why I couldn't find it in Kent's over here, Hampshire's over here. Doesn't matter. So here you go. Here's our 72,000 instances of crime, of antisocial behaviour in Hampshire. And that's something that I'll be showing you more of when we come to the summit session. Okay, so over this last 40-45 minutes, hopefully I've given you an introduction for what we're going to cover in my session at Summit. We're going to go down a lot deeper into Azure Resource Manager templates. We'll cover more of Elasticsearch, and we'll have a bit of fun at the end with dashboarding. Can't guarantee the dashboarding will go to plan, but we'll have a lot more fun with that. So let me just get the slides back up. And now, I don't know if there's been any questions asked, but Praveen will let me know and I'll try to answer them. So thank you very much for listening to me. I know that if you're in the West, it's very, very early for you, and if you're in the Far East, then it's probably very late for you. So if there's anybody there, thank you very much for listening to me, and anybody in the UK as well. So thank you very much.
Hi, Alan. We don't have any questions as of now.
Woo!
Well, I thank all the participants. We still have a few minutes left, so if you have any questions, please feel free to type in. So we have a question from Craig Wallace. What is a shard?
Okay, so when your data's indexed, what happens is it's broken apart into shards. Those shards will make up a document, but then those shards then get replicated over to other nodes within your cluster. So it means that if you lost a given server, a given node, those shards, copies of those shards would be available on another server, and Elasticsearch would then be able to get the data from that other node. If you then fix whatever was wrong with the node, you add the node back to the cluster. What happens is Elasticsearch says, oh, hang on, I need a replication factor of X on these shards. So what I'm going to do is I've got another node that I can replicate to, and data will start replicating. Your shards will start replicating over to that other node. It's You see it with Hadoop and any other NoSQL solution. So they're not stored in the entirety. They're broken up into shards, and then those shards generally are replicated somewhere else. Any other questions?
Yeah, so uh, Craig says, so it's like an internal load balancing or replication.
Yeah. Yes. Go on then. Yes. Yeah. So your documents are broken up. So the JSON that you push through, they're broken up into shards, and then the shards are replicated. So yeah. So an internal load balancer. I like that. I might use that.
Okay. So thank you all for attending building a scalable analytical solution using infrastructure as a service and Elasticsearch. I would like to thank Allan for his time and expertise. Again, I would also like to thank our presenting sponsors, Microsoft, Idera, and Dell Software, and our supporting sponsors, Pyramid Analytics, SQL Sentry, and HP. We hope you have enjoyed this session as much as I did. Follow along on the social media with the at PASS24HOP and share your thoughts on the event with hashtags on Twitter, PASS24HOP and SQL Pass. And Allan will be presenting at PASS Summit 2015 this year in October. So he will be presenting a half-day session of 3 hours on the same topic that we have discussed now, building a scalable analytical solution using infrastructure as a service and Elasticsearch. So you could use the discount code 24HOP15 to save $200. And if you have any further questions, you could communicate with Allan, the Twitter handle. So thank you all for attending this webinar, and stay tuned for the next webinar in line. So it's advanced scripting using SSIS script tasks and components with John Welch. So it would be happening in few minutes shortly. So thank you all for your time. Thanks.